I see. Okay, so we'll quickly start by talking about some of the terminology involved in this chapter. So, if we generate an angle, okay, theta, then we refer to this side as the reference side, and this side as the terminating side. Okay, and if we talk about positive angles, we talk about angles which are measured from the x-axis, okay, or from the reference side, which in this case is the x-axis, in an anti-clockwise direction. That's positive. Whereas negative angles are measured in a clockwise direction from our reference side, that is the x-axis. So here that could be something like theta is plus 45 degrees, whereas here this is theta is minus 45 degrees. And it's just worth noting that if we have an angle and it's equal to something like minus 45 degrees, then that is the same as plus 315 degrees, i.e. 360 degrees minus 45 degrees. And if we just talk for a second as well about signs, positive and negative signs and angles. And it's just important to realise and note and know that minus cos theta is not the same as, it's not equal to cos of minus theta. Okay, so if we have an angle of 45 degrees, minus cos of 45 degrees is not the same as cos of minus 45 degrees. And if you actually type that into your calculator, minus cos 45 degrees is minus 0.7071, whereas the cos of minus 45 degrees is equal to 0.7071. Or you could tap in the cos of 315 degrees and you'll get this as well. So just know that, you know, where the minus sign is placed is important, okay? And we've seen in class how we use the unit circle to generate the cast rule. And if we generate an angle in the fourth quadrant, then the coordinates, the xy coordinates, are the same as the cos of this reference angle, comma, minus the sine of this reference angle. Okay, so just to note that, you know, these are similar to the xy coordinates of a point on the unit circle, which we've seen in class. Okay, so let's use cast, or the cast rule, to find the sine, cos and tan of a main angle. Now we'll talk about main angles in a second, and with respect to the reference angle theta. So the main angle is the angle that's greater than 90 degrees, because we can use the trig ratios to find the sine, cos, tan of any angle between 0 and 90 degrees in a right angle triangle, but when they're bigger we have to use the cast rule. Okay, so we'll have a main angle for which we're trying to find the sine, the cos or the tan of, and we'll find that by noting or becoming aware of this reference angle that's generated by the main angle. So in the first quadrant, our main angle, if I was to draw a main angle here, that's actually the same as our reference angle theta that's generated. Okay, and the sine of this main angle is the same as the sine of the reference angle generated, and the cos of the main angle is the same as the cos of the reference angle generated, and the tan of this main angle is the same as the tan of the reference angle generated. For example, the cos of 60 degrees, our main angle, is the same as or equal to the cos of the reference angle generated 60 degrees. So it's kind of the same in the first quadrant, but in the second quadrant it gets more interesting. Generate a main angle here, that creates a reference angle here between the terminating side and the x-axis. Okay, and the main angle is equal to 180 degrees minus this reference angle. And the sine of this main angle is equal to the sine of the reference angle. The cosine of the main angle is equal to the negative cosine of the reference angle. And the tan of this main angle is equal to the sine of the reference angle over the negative cosine of the reference angle. So for example, if I have a main angle of 130 degrees and I want to find the cosine of 130 degrees, then that's equal to the negative cosine of the reference angle generated, which is 50. It's minus cosine 50 degrees, or minus cos 50 degrees. If I move into the third quadrant, and I note that I generate this main angle into the third quadrant that ends at the terminating side, I also have this reference angle generated, theta, and the main angle is actually equal to 180 degrees plus theta, okay, and the sine of this main angle would be equal to the negative sine theta. The cos of the main angle is equal to negative cos theta, and the tan of this main angle would be equal to negative sine theta, the reference angle, over negative cos theta. So for example, if I was asked to find the sine of 210 degrees, then I would draw my 210 degrees, I would take 180 from that and realise that my reference angle here would be equal to 30 degrees, and I simply look to see that the sine of this main angle would be equal to minus sine 30 degrees. If I move into the fourth quadrant, my main angle here spins all the way around to a terminating side in the fourth quadrant, generating a reference angle. My main angle size is 360 minus this reference angle theta. The sine of this main angle is equal to the negative sine theta. The cos of the main angle is equal to the positive cos theta, and the tan of this main angle would be equal to the negative sine theta divided by the cos of theta. So for example, to find the sine of 300 degrees, I generate my 300 degrees, it stops there. The reference angle is 60, so the sine of 300 would be equal to negative sine 60 degrees. Now, you just note that, where are we getting the sines from? It goes back to originally doing the cast and from up here, okay, that, if we have a point here in the first quadrant, it's plus x plus y, plus cos plus sine. If it's in the second quadrant, it's negative x plus y, so it's negative x and plus y, so it's negative cos plus sine. When it's down in the third quadrant, it's both negative x, it's out here, and it's negative y down there, so it's negative cos, negative sine. And when it's in the fourth quadrant, it's actually positive cos, because we're going this way in the positive x, but it's negative sine because it's down here. Now, what's really important about trigonometric functions is to note and realize that two main angles can have the same sine, or two main angles can have the same cosine, or two main angles can actually have the same tan. So two different angles, both main angles, but they can have the same sine value. Okay? And how and why is that? Well, if we think about two angles having the same sine, remember that sine refers to the y coordinate, okay? So we could have an angle here, okay, and that's our first angle, and it has a sine value, so that's the same as its y coordinate value, the distance from here to here. So in theory, we can have another angle here with the same y coordinate value, the same sine. Okay, so there's one angle here, and there's our second angle. So the sine of the first angle is actually equal to the sine of the second. And that's a positive when the y coordinate is positive, or positive sine. But we can also have an angle here. Okay, this first angle, and that has a value here, it's a negative y value, but we can also have another angle here, another main angle that goes all the way around to there. They both have the same y coordinate, so the sine of the first is equal to the sine of the second. And if we think about cos, we're moving into the x axis, So this time we can have an angle here, our first angle, with a positive cos. But we can also, that's a particular value from the origin to there. But we can also have an angle here with a positive cos as well. So that the same x-coordinate, these two points, so the same cos of the reference angle generated in here. And it's the same then if we go to the other side, to the negative side of the x-axis. We can have an angle with a reference here. This is our first angle, and that has a particular cos value, particular x value. It's the same, okay, it's negative, but it's the same as this point here. So this is our second main angle. So this angle has a cos, this angle has a cos, and both those two cos values are the same. Like here, this angle has a cos, and this angle has a cos, and they're the same as well. And for our tans, if we just remember that tan is positive in the first quadrant and the third quadrant, then this is our first angle, main angle, this is our second main angle, and they have the same tan value because the ratios would be the same. So let's look at some examples. Okay, what angle between 0 and 360 has the same sine as 112 degrees? Well, to solve this, let's draw our main angle of 112 degrees, and let's realize that that's generated a reference angle here of 180 minus 112, 68 degrees. So this angle is 68 degrees, and this angle here is also 68 degrees. Sorry, this reference angle is 68 degrees, and this is the same, 68 degrees. They have the same y coordinate. Therefore, one angle is 68 degrees and the other is 112 degrees, i.e. the sine of 112 degrees is the same as the sine of 68 degrees. Second example. What angle has the same sine as 300 degrees? Well, let's draw our main angle of 300 degrees. Let's realize that it's generated a reference angle of 60. So we've 60 here and we've 60 there because they have the same sine, the same y coordinate, same sine, so it's the same reference angle of 60. And that means that it is 240. Okay. And our other angle is the original 300. So our answer, is 240 degrees. In other words, the sine of 240 is the same as the sine of 300 degrees. Okay, find to the nearest degree two values of A if the sine of A is 0.2167 and A is between 0 and 360. In other words, they're asking us to find two main angles, A, which have the sine of A, or whose sine is 0.2167. So in other words, we're looking for two angles. The sine is positive, so they're above the x-axis. So we've one here, our first A, and we'll have a second value for A on this side as well. Okay, so the first thing we do is we find if we know that the sine of A is equal to this, then A is the sine inverse of that. A is 13 degrees. So that's our first value for A, is 13 degrees. In other words, the sine of 13 is that. Okay. Now if that reference angle is 13 degrees, so is that. So our second A must be 180 minus 13 degrees. That's 167. And you'll find that the sine of 167 is this value as well. So we've found two values for A, 13 and 167, whose sine in this is 0.2167. Okay, and we knew how to draw the diagram because the sine refers to the y. It's positive, so there's one, there's the other, and we found the first one before finding the second. Okay, find correct to the nearest degree two values for A if cos A is equal to minus 0.8428. So we need to find two main angles A whose cos of A is that. Okay, so the cos is negative, so we're looking at an angle here and an angle there. First one, second one. We have a reference angle generation in both cases. So if the cost of A is that, then cos inverse of that is 147. So that's our first angle. Now if that's 147, our reference angle must be 33. So our second angle must be 180 plus 33, 213 degrees. Find two values for B if sine B is equal to this. Okay, so we're talking about sine, we're talking about negative, so there's one angle, there's another angle, and what we then, so we're looking to find whatever our first B is and our second B. So we let sine B equal that. B is minus 44 degrees, so this is minus 44 degrees here, so that's minus 44. This is the same, so it's 44 in this case. So our first B goes to here, which is 180, sorry, we can go straight, we're actually going straight to this one. 360 minus 44 is 316, and our second B then is just to this first angle here. It's 180 plus 44 is 224 degrees. Sixth example, find two values for C if tan C equals 0.9325. Okay, so it's positive tan, so it's this angle and this angle. So it's our first C and our second C. So we'll look to find, see how we go. Our tan C is equal to that value, so C is 43 degrees, that's our first one. And if that's 43, this is 43 here. So our second one must be 180 plus 43, 223 degrees. If sine theta equals a half, find two values for theta. Now just be careful here, we'll watch out for the notation with theta, because before we've had if sine A equals a half, find two values for A, because we like to reserve theta as our reference angle in these problems, okay? So we'll just keep that in mind. So we're looking for sine theta is a half, it's positive, so that must be one of them, this must be the other. It's the first main angle we're looking for, and this is the second main angle we're looking for. So sine theta is a half, theta is 30, so that means that's 30, means that's 30, so our first angle is 30, and our second is 180 minus 30 is 150. If cos theta equals 1 over root 2, find two values for tan theta. Again, we have to be careful with our signs for our reference angle. So if cos theta, so we're talking about x coordinates here, is positive value here, this is a positive value, then that's one angle and this is the other angle. We're looking for this main angle first and this one second. So cos theta is that, theta is 45, so we simply write 45 in here. So we have our first angle and our second angle is 315. Now we look for the tan of the first angle is 1 and the tan of 315 is minus 1. Question 11, if tan of A is 1 over root 3, find two values for the cos of A. Okay, so the tan is positive, so it's first quadrant, third quadrant. There's our reference angle there. This will be our first main angle and our second main angle. So tan of A is 1 over root 3, A is 30 degrees, so the first one is 30, the second one's 180 plus 30 is 210. So now we have to find the cos of those two values, and we get root 3 over 2 and minus root 3 over 2. Okay, question 12, if sine theta is minus root 3 over 2, find two values for cos theta without using a calculator. Okay, so we're talking about sine, it's negative, so we're talking about two angles here, they're reference angles, so we're going to look to find this one and that one. So sine of theta is minus root 3 over 2, so theta is equal to minus 60 degrees, okay, so we can call that one minus 60 degrees. This must be 60 degrees as well. So our first angle tracks around to here and our second to there. And we're not using a calculator now, so we want to find the cos of the two angles, the cos of 240 and the cos of 300. Well, from the beginning of this video, cos of 240 is the same as minus the cos of the reference angle, which is 60 degrees. Minus the half, and the cos of 300 is the same as the cos of the reference angle, which is 60, and it's equal to a half. Okay, 13. Find correct to the nearest degree if sine A is minus 4 over 5 and cos A is minus 3 over 5. So we're looking to find this, this main angle A. Okay, and here's our reference angle that's generated. And these are the coordinates of this point. Okay, so the tan of this reference angle is equal to the sine of the reference angle, which we have, which is here, divided by the cos of the reference angle. So the tan of this reference angle is 4 over 3. So this reference angle is 53 degrees. So A must be 180 plus 53 degrees, 233 degrees. And question 14, if sine B equals 3/5 and cos B is minus 4/5, find the value of tan B without using the calculator. Okay, so let's just draw it first. Okay, so we have minus cos, we're in this quadrant here, a positive sign. So we're in this quadrant here, and the coordinates are minus 4 over 5 and 3 over 5. And B generates this reference angle here. So let's find the tan of the reference angle. That's equal to minus 3 over 4. And the tan of the main angle is equal to the tan of the reference angle. That's equal to minus 3 over 4. And if you want to check, you could use these ratios here and find that B is actually 143 degrees. And you can check to see that the tan of 143 is the same as the tan of 180 minus 143. Okay, 15. If tan B equals 1 over root 3, sine B equals minus 1 over 2, find cos of B. Well, tan of B equals sine B over cos B. Cos B, therefore, is equal to sine B over tan of B. So we divide those. Cos of B is equal to minus root 3 over 2. Question 16. If the tan of A equals a half and A is between 180 and 270, i.e. it's in the third quadrant, find the sine of A in surd form. Okay, so let's just draw our reference angle, and we know it's 2. This tan is equal to opposite over adjacent, so the opposite is 1 over the adjacent is 2, and that means that this is root 5 because that's square root of 2 squared plus 1 squared. So the sine of theta is 1 over root 5. It's the opposite over the hypotenuse, and the cos theta is equal to 2 over root 5, and the coordinates of this would be minus 2 over root 5 and minus 1 over root 5. Okay? So let's think about A then. This is our reference angle that's been generated by our main angle A. They are the coordinates. But remember that the sine of A is equal to minus the sine of this reference angle. Sine of the reference angle is 1 over root 5. So the sine of A is minus 1 over root 5. Now, question 17. Find the sine of 420. Well, 420, we go around 360 and around some more, is the same as the sine of 60. That's equal to root 3 over 2 from the log tables. The cos of 495, we go around 360 and we go further 135 degrees. And the cos of 135 degrees is equal to negative cos 45 degrees. It's minus 1 over root 2. And the tan of minus 120, well, there's minus 120 there. Okay, that's the same as 240, same as tan of 240, and the tan of, 240 is in here. The tan of 240 is the same as our reference angle here is 60, same as tan of 60 degrees, it's equal to root 3.